we move ahead to the next module of stationary waves. In this module, we are going to do MCQs which are based on the concept of string, and this is part 2. That means we'll be moving ahead to solve the problems on the concept of string. The first problem, it says that the fundamental frequency of a wire stretched with a 2 kg weight, that means the tension is given, is 100 Hertz. That means tension and frequency is being provided. They're asking the weight required to produce its octave will be. Now students, remember, octave means twice the original frequency. So to produce octave, how do I move ahead with the solution? First, the options which are given are 4 kg weight, 8 kg weight, 12 kg weight and 16 kg weight. To move ahead with the solution, we know that the octave means the twice the original frequency. Can I say frequency is directly proportional to square root of tension? So I can say that as N2 by N1, which is equal to under root of T2 by T1. So alone T2 will be equal to, can I say, T1 multiplied by N2 square upon N1 square. We obtain this by squaring on both the side and taking T2 only on one side. Because we need to find out the weight required in the second case, that is why T2 is our sole intention to find out. To move ahead in this problem, I know that T2 was given by T1 multiplied by 2N1 square upon N1 square. Now why is this 2N1 coming? Can I say second frequency has to be octave, that means twice the original? So can I say 2N1 the whole square upon N1 square? Now after solving this, I know that I'll get it as 4N1 square upon N1 square. When N1 square and N1 square will get cancelled, the answer will come out to be 4 times T1. Can I say tension 1 was given as 4 into 2. So can I say 4 into 2 will give me 8 kg weight, and 8 kg weight is the option B. So option B is the correct option, students. Moving ahead to the next problem, it says the frequency of the second harmonic emitted by a wire is 200 Hertz. The frequency of the third overtone will be. The options are 300 Hz, 400 Hz, 500 Hz or 600 Hz. To solve this problem, students, we know that the frequency of second harmonic is usually 2n, and 2n is 200 Hz. That means, can I say n will be equal to 100 Hz. So the fundamental frequency is 100 Hz. But what do I need to determine? I need to determine the third overtone. Students, I know that third overtone is basically the fourth harmonic. So can I say frequency of third overtone will be 4 times n, that is 4 into 100, which will come out to be 400 Hz. So students, 400 Hz, if I see in option, it is the option B. Moving ahead to the next problem, it says stationary waves are produced in a stretched string. The length of the string is 120 centimeter. If the string vibrates with 6 segments, that means 6 loops, and if the frequency of vibration is 20 Hz, the frequency is given as 20 Hz, then the velocity of the waves on the string is given by. Students, we know that 6 segments, meaning, can I say 6 loops are formed? So if I say 6 loops, that means the length of segment or the length of overall length is 120 centimeter, which is 6 loops. That means 6 multiplied by lambda by 2, because length of one loop is lambda by 2. After solving this, I know that 120 comes out to be 3 lambda. So can I say alone lambda will be equal to 120 by 3, that is 40 centimeter. Now I know that frequency was given by 20 Hz. Now I have wavelength, I have frequency. I need to determine the wave velocity. V is equal to n lambda, as we all know. So can I say n, that is 20 Hz into 0.4, because it is 40 centimeter. So after solving this, I get the answer as 8 meters per second. So students, with the help of this module, I came to know that the last problem gave me the answer of velocity of the wave as 8 meter per second, and this is the solution for the problems which are based on the concept of string. So students, will be meeting ahead in the next module, again continuing the same topic but in further detail. Thank you.